Going to talk about how we can collect routing information with Rotonda. Rotonda is a application to build BGP applications. I should say a framework maybe. Well, he's the expert, so I'm going to leave it to him. Take it away.
The expert, okay. No pressure. Hi everyone, my name is Luuk. I'm with NLNet Labs and we make open source software. And I guess if you're in this room and you've heard of us, then it's either because of our DNS stuff or our routing security stuff. And most likely, if you heard of us, that's because of Routinator, our RPKI validator. And when people started using validators a couple of years ago, not necessarily Routinator, we got some worried noises from operators saying, you know, we want to do this route origin validation, but you know, making sense of our networks is already hard enough, and now there is this extra RPKI thing directly influencing the routing decisions. You know, stuff gets a little bit less tangible, a little bit more scary, if you will. We were like, yeah, you know, that sounds fair. At the same time, BMP appeared on our radar. That seemed to get some more traction, and we thought, you know, maybe we want to become an expert, and we should make something that collects routing information, also feeds in RPKI information, and while we're at it, you know, make it super flexible, and oh, it should also scale. So, you know, how hard can it be? Today I would like to present to you Rotonda. That's what came out of that crazy idea. It's not done. We're far from done. There will be rough edges, and you will see them. But at this point, I think it's very, very usable, and I hope that at the end of this presentation, you will have some creative ideas of, hey, maybe I can do this and this with Rotonda in my network to solve this and that. So, let's go. Before we dive into the components that comprise Rotonda, if I say BMP, does everybody know what I mean? Who here considers themselves somewhat familiar with BMP? Somewhat familiar? Anybody that uses this on a daily basis, perhaps? No? Most of you are wondering, why the hell is this guy talking about bitmaps? Yeah, okay. Okay, that's really unfortunate because I only have a super criminally oversimplified single slide to explain BMP, which will get us through this presentation. But after the break, Thomas, is that you? Yeah? Thomas will do a proper introduction of BMP, and then he can correct me and make fun of me for 50 minutes straight. So, but for now, let's say we're AS1, and we have a BMP station, think BMP collector, configured. What will happen is whenever we get an update from our peer AS2, what goes over the TCP connection to our BMP station is basically that update, but then wrapped with some additional information. Most importantly, this per peer header that said this is an update that came from AS2. So this way, we can actually export information on all the sessions that we have on our router towards this single station over this single TCP connection. Again, this is criminally oversimplified, but for now this is good enough. If you understand that we can export loads of information this way over the single connection. Now, Rotonda. At the heart of Rotonda there is what we call the store, the Rotonda store. And this is our own in-house built, custom tailored in-memory database, which is tailored to store large amounts of keyed on prefix type information. So think unicast routes, right? And at this point, I guess it's important to notice that everything you see in the, is it dark blue for you as well? In the dark blue square is part of Rotonda, which is one single Rust binary, right? We don't rely on any external database whatsoever. This is all within our Rotonda binary. So how do we feed stuff into the store? Surprise, surprise, with BMP. We have a BMP connector, and not only will BMP give you information about all the sessions of all the peers on that router that is exporting the BMP feed, it will do so for multiple RIP views, if you will. So it can export information from your adjacent RIP in pre local policy application, post policy application, and the same for your adjacent rip out and also for log rip, right? And you can get this BMP stream from multiple routers, right? So this BMP ingress component is really like the fire hose of the application, if you will. Now, for those older platforms that think they speak BMP, but they don't do it, or they don't do it really well, there's also a BGP in connector, right? For us, that's really a passive component. Like we will never send out any updates. This is just a BGP session that does the bare minimal to keep the session alive, so it can ingest updates, and with that monitor the router that you connect this way, right? So this is really a poor man's BMP, if you will. And that might be less interesting for most of you here, you can also feed in routing data from MRT files. If you're a student, researcher, this might be interesting for you. And we use it for testing. Then, getting stuff out, surprise, surprise. JSON, many gigabytes of JSON. If you want it, you can get them here. And another way to get data out is either via MQTT or write to a file. So these are basically all the components. And as you can see, they're a bit awkwardly positioned on the slide. And that's not because I've been using LibreOffice, because that actually works very fine. I can actually recommend it. It's because we're missing one key piece here still. And that is Roto. And Roto is our own in-house developed programming language that we use for the filters. And now, at least some of you are going like, oh. So, they took like 3 of the most popular scripting languages, took the syntax, mashed it together. There's like the shitty DSL that came out of it with its own peculiarities, right? It doesn't work at all, and they smacked a nice logo on it, and now he's gonna act all cool about their programming language, right? Well, no worries, because we don't have a logo. And I'm actually not sure why we still don't have a logo, because I think we've earned it by now. But that's something that we'll work on, so next time we'll have it. But now I will then start acting all smug about Roto, because it's actually pretty cool. So, it does indeed look a lot like scripting languages that we all know, right? I guess all of you in the room, if you see this snippet of code, regardless what it actually does, you can make sense of it, right? And that's what we're after. We're after a high-level feel to give you all the flexibility and also the performance, but I will get to that. And I was only half joking about, half-assing multiple language into a quarter-assed one. We do realize that we're, pushing yet another language onto people, which comes with a cognitive burden. So we want to make it as easy as possible to start using this, right? And we want to make the experience as nice as possible. So syntax highlighting is one of these things, in addition to, having this high-level feel, but we can actually do something far, far fancier here. Roto is strongly typed. So if you're making a mistake like I did on this slide, if you look at the second line there, instead of an ASN, I accidentally put in a prefix, right? It would be very annoying if this is triggered at runtime while you're trying to, look into a packet, and this doesn't work and you get an error. Instead, we can actually, before you start the entire thing, type check this before we compile it and tell you, wait, we want an ASN here, but you gave us a prefix. And we even have the curved lines, you see? That's very fancy. That's better than a logo. So after the type checking, and after preventing all these mistakes, Roto gets compiled. And we're leveraging this thing called crane lift, which is a compiler backend in Rust, which then eventually let us compile the stuff to native machine code. So now we have something that is super high level, gives you the high level feel, gives you all these tools and handles to work with it in a nice way, get you all these actual
proper error messages and eventually compiles into something that's supposed to be fast, right? And with this, we can do a lot of cool stuff. Because now we can give you the tools to become very flexible in all these parts where you see the little cogs at almost zero overhead, like compared to if we would have to implement the same logic hard-coded in Rust for you, right? There's almost zero overhead compared to that. So let's see how we can then use it. So I'm highlighting the two of the ingress components here, so the BMP and the BGP one. And these are the examples that I think we actually package in the releases. As you can see here, the type system helps you reason about the filters that you can write, right? For the BMP filter, you actually have to work with this thing called the BMP message. You get the entire message that you can look into, that you can log on certain things you want to log on, send out events, whatever. For the BGP one, it's the BGP message. And although I said they are very, very similar in the oversimplified BMP 101 slide, they are actually different, and this allows us to give some extra handles, for example, on this BMP message, right? And if you make a mistake, the type checker will get that for you before you actually spin up the application. So for example, in BMP, we have multiple message types. One of them is peer down. It says, your session with this and this peer has gone down, right? Such a thing does not exist in that sense in BGP, so you can't do that in the BGP filter, but you can do that in the BMP filter. And if you can read it, the contrast might be a bit nasty. Things like check for ASs in AS paths, you can do that on both of the message types. Check for whether a community is part of the message, you can do that in both of on both of the message types. So those are some simple examples that you can use to act on the entire message, perhaps drop it if you don't want to store it, or a log if you see a certain community or a certain AS, that kind of stuff. Now, after your message has passed through these filters, it, as we call it, explodes into multiple routes, right? If you have a BGP update, it can pack 10 or 20 or 1,000 prefixes. In the BGP filter or the BMP filter, you work on the entire message. Just before the RIP, you have another filter that can act on individual routes, individual prefixes. And then you can do all kinds of other stuff. So we actually have another, let's call it a setup function that I didn't show, where you can define your own lists. For example, lists of ASNs or lists of prefixes. And in this case, we have a list called my prefixes, haha. And I want to check if stuff that comes in is actually on my list. And if it's on my list, what do I do in this case? I just send out a log thing, which will go on my MQTT bus. Now, we can do this here, because here we have access to one single prefix, right? In the BGP update, you might have 20. You don't go looking for a specific prefix in there. That's what you do here. Again, different type. It's tricky if you start out writing rotor scripts for this, but the type checker will definitely help you. Now, this is where the fun starts. We also have an RTR in component, right? Because we need this RPKI information to be fed into Rotonda. And if you look closely, you see that there's multiple new cogs here. One is near the RIP. Because when you have an RTR component configured, now, when you look at the individual route, you can call check ROV on your route. And now we can do route origin validation on every route that comes in. And the good thing is, we don't drop anything, right? We just mark something as invalid or not found or whatever, and we store it. So even if you export multiple RIP views, say adjacent RIP in free policy, and maybe you do drop invalids on your platform, then we can still see all the routes stored in Rotonda. So you still get the full view. And I will show later in a API output where this appears. But there's another place where we can now do some roto stuff, right? because also here we can hook in to an event, namely the event that new RPKI info comes in, right? So the previous one is where a new route comes in, either via BGP or BMP, and we can call check ROV, but there's another event, which is updates from the RPKI that are processed by your validator that produce VRPs, right, verified ROA payloads, that flow in via RTR. And this is another example where we use these lists of my ASNs and my prefixes. And you can, for example, log stuff that you see, right? So if you want to keep track of something that has to do with one of your ASNs, you can do that via these ways. But if you're using these two scripts now, we can actually throw in a third one for free. And this one is the actual cool one. Remember, we have the routes that come in. We do the check ROV. We have the RPKI updates that come in via RTR that are flowing through to our RIPs and get applied there. But then there is this one that actually is a callback that will be executed for every route in your RIP that was affected by the just processed RPKI update, right? So this thing gives you back something of type ROV status update, and we can bike shed that name, but this will give you the prefix that was just affected by the RPKI update. It will give you the previous ROV status, and it will give you the current ROV status. So now you can actually check on this, like if the status has changed, I don't care from what to what, but then I check, is the new status actually invalid? You know, I would like to know something is happening. Or maybe if this concerns one of my prefixes, I always want to send out an event, write something to my log, whatever. And this is what that looks like, and I hope, yeah, that's quite readable. So this is actually a combination of some debug output on the first 5 lines, and then 7 lines of output that came from that roto script. Somebody created a new ROA, and all of a sudden this prefix is now covered, right? So it cannot be not found anymore in the ROV algorithm. But it's not originated by the ASN that is on that new ROA. So the new ROV status is invalid. And we don't see this one time, we actually see this for all the 7 routes that we had in our RIP at this point. So this way you can actually see how RPKI information affects stuff in your RIP, in your networks. So there. Then, how can we get data out? It's a typical JSON API. We just revamped this. You can ask information about ingresses. For us, that's like a BMP session actually describes multiple ingresses for every BGP session that is monitored, etc., etc. But the interesting stuff, I keep doing this, the interesting stuff is in the RIPs, routes, endpoints, where you can query for the prefixes stored. There's 2 variants there. The top one gives you everything in that RIP. That will really give you gigabytes of JSON. Or you can search for a specific prefix and ask for less specifics and more specifics. And the store is really tailored to do that in a very fast way. Now, on the next couple of slides, you'll see some output, which is data based on route views data. Route views is this collection project. We're collaborating with them since a couple of weeks. We have an internal BMP feed from them, which is really cool because it allows us to test and stress test Rotonda, and for them to see whether Rotonda can be helpful for them. So one of the examples from the endpoint, if you ask for a certain prefix, I think this one is ours, you'll see that if there's a hit, you will get back the prefix, and you'll get a routes thing, which is actually an array, right? Because we might have tens of entries for this prefix, adjacent RIP in pre, adjacent RIP out post, etc. And from different sessions, from different peers. And you'll see this is one that is from adjacent RIP in post. There is the RPKI status, so apparently we did the check ROV on this one. And of course you get all of the typical path attributes, right? Here you see AS path and communities. We actually store everything. So we don't strip or drop any attributes. Of course, we need filtering because this is all too much. There's your typical thingies like I want to filter on origin ASN on a community. I want to filter on the ROV status, yada, yada, yada. The most important part here is that these are all Boolean ended, if you will. We keep this thing simple. We want to give you all the flexibility, but we don't believe that an HTTP API is the right place to do that. Right? Even if we would manage to fit in all the possibilities, it will be cumbersome and error-prone. So we let you write your own endpoints using Roto again. If you say function Roto is, for example, hidden hop, like here, and you have in your Roto script the finder function, that will be called, and your result set will be filtered in that way. So this is that hidden hop thing. This is just a cooked up example. You see that the type is path attributes, so you can filter on anything in the path attributes. And if the end result of this filter is reject, it doesn't become part of the result set. If it's accept, it will be returned in the JSON response, right? Now, this is a bit verbose, and this is where things might be better in the future in Roto. But what this basically does is, I'm checking, is there an OTC, an only to customer path attribute for this route? If there is none, we reject. That's the bottom line. If we have one, we check. Is there an AS path for this route? Which in inter-domain routing, most likely there is, right? And if we have both, then we're going to do our actual check. Is the OTC in the AS path, yes or no? And if it's not, then I want to see this path. And honestly, I just thought this up. I didn't think anything of it. But does anyone want to make a guess what kind of stuff that you see if you run such a filter? Does anyone expect their network to pop up here? I know there's at least one. Who's this? Who's this? It must be criminals. Who's this? Ja, daar. You wanna make a guess? Yeah, that's your route servers. And that makes sense, right? Because this OTC thing, it's RFC 9234 with all the roles. Yeah, so you have a route server client, route server server, somebody on the path sets the OTC to their ASN, but apparently it doesn't appear on the AS path. So I guess this is some stupid trick to find, like, ARM6 route servers. If you run this over the whole set, you find other IXs as well. Anyway, that's a contrived example. The main message there is, we don't know and we don't care what you would like to query exactly, right? We give you the tools and the power and the flexibility to define that for yourself. Another thing, metrics. We do the Prometheus-style metrics. We have some built-in ones. I will be honest, those are not in a great shape right now, but that doesn't matter because you can define your own using Roto. And this is one of these things that, sure, is still a bit rough, and we need to work on this, but it also works. It's available right now, and it lets you define your own custom metrics surrounded by your own logic in runtime. So let's say, and this is actually something that a operator asks us, like, I don't care about a withdrawal or a announcement. That's like baseline noise. If there's messages coming in with, say, 5 or more withdrawals in one go, packed in one update, that typically means something to me. So that's what I want to see. So that's simply solved for us now with 4 lines of Roto. We just check the number of withdrawals in one PDU. So this happens in your BMP or your BGP in filter. And if it's more than something, you just write out this metric. So this is a special thing which actually atomically keeps track of the counter. There is increase counter, there is set gauge, your typical Prometheus things, which ends up as a Roto user-defined packed withdrawals metric. So again, perhaps a silly example, maybe it doesn't apply to you, but you have the tools to customize this and leverage your monitoring and your alerting as you're using right now. So, big blank blue spot. We need to stream out at high volume. We somewhat settled for Kafka now, but if anybody has better ideas, please let us know. Concluding, with Rotonda, we're able to store loads and loads and loads and loads and loads of unicast stuff, and you can get it out with your favorite curl. And there is a web UI, but I'm not going to show it. Soon, we'll have non-unicast stuff. Most notably, that's VPN stuff and FlowSpec. Operators also asked us about BGP LS, which we'll look into, and everything with and without AdPath. We already collect SPA stuff. We don't expose it yet in the Roto script. We are working on persistent storage, CLI, all that kind of stuff. You can try it out. It's all open source. It's freely available. We have packages in our own repositories. There's documentation. And there is a GitHub. You know how this works. Oh yeah, and there is a release for today with all the stuff that I've presented here. And perhaps most importantly, please help us out. This is super tricky. We don't have a network. We don't have any routers. You know, the unicast stuff is available with ripe RIS, with route views, but the non-unicast stuff is actually really hard to come by. So, you know, if you can share PCAPs, maybe, you know, you can spin up a VM in your testbed. That would be great. That's super helpful for us. And please don't think that, you know, I have only a super vanilla router running a vanilla version with a vanilla BMP exporting config. There are so many edge cases in this stuff, and the BMP protocol is still evolving. It will be useful. We will hit bugs, either on our side or on your side. If you want to know more, I'm here all day. Where's Jasper? Jasper is here all day. We love to talk. If you want to know more about Roto, this is Terts. He's the guy that made Roto the magic that it is today. He's our colleague who is not here, but he will do an in-depth talk about Roto somewhere next week at Eurorust. So if you're, you know, half the compiler nerd he is, make sure that you tune into the live stream and nerd out there. That will be very interesting. And with that, I'm only 3 minutes over time, I think. And I say thank you very much.
You're perfectly on time. Excellent. We have room for some questions even. So please go ahead.
Hello, Molly Miller, Flying Circus Internet Operations. You mentioned plans to extend this for L3 VPN and BGP LS. Would there be interest in maybe extending this for EVPN and that whole bundle of complexity? Because one thing I found working with EVPN VXLAN is there's not really a lot of good tooling for getting good observability.
I think for EVPN, we actually have all the parsing stuff ready. This is mostly like gluing all the bits together. So that will be one of the things that we'll support. So, you know, to be honest, after working with anything BGP, we realized quite late in the game that, you know, this is just one big key value store, if you will. So now I think, looking at Jasper, like we rename things even in the backend to like blob to blob store, and everything is basically, you know, it can be anything. So whether that's EVPN or L3 VPN, at some point we will support that. Yes, of course we do the proper parsing and, you know, sanity checks, sure. But and like again, we don't run networks, right? So we don't know what people really want. So this type of input is actually super valuable for us.
Thank you very much.
Next question.
Hi, Paul de Weert, Rijp NCC.
Hey, Paul.
Question, you mentioned Kafka for the streaming out. Asking for a friend. How about Kafka input?
Yeah, we should do that. We should.
Please.
We should do that. I was cleaning up the GitHub repository and I found an issue for that. That's over a year old. It is on our radar for sure, but so are many other things. So you know, but at this point we really lack the high volume streaming out of stuff, right? Like if you accidentally, and I've done that on my laptop, accidentally ask for the entire contents of Rotonda when you are ingesting like 3 route view vantage points in JSON and you pipe it through JQ, yeah, that's no fun at all. So that's really a missing part right now, and I guess that's less so for the Kafka ingress, but it's likely we will combine those two like in one thingy thing. We're going to combine ingress and whatever that means for Kafka.
Awesome.
He is going to combine ingress and egress for Kafka.
That was Jasper. Who
I have never
that.
seen that
Yeah,
man.
no, Jasper.
Yeah.
I guess.
All right. I'm looking at our moderator online. Are there any online questions? All right. Please go ahead.
Yeah. I guess BMP is a splendid. Sorry, thank you. Bart Dorland, self-employed. Currently at Imperva, and I implemented BMP as well. Seems like a hot topic because I was, I guess, the third one wanted to talk about BMP. Congratulations to you guys talking about it in the next one. Nuts might be one instead of Kafka. Supposedly easier to configure and to maintain, so you could try that one. I did it with the Cloudflare package BBMP to Kafka. They have it based on biorouting in Go. I was wondering if you get to the actual combining all of that, I ran into database challenges mainly because of the high volume of data and wanting to store pre and post on a service provider on 60 plus POPs with a lot of service provider connections behind that. We wanted it first all, and then we ran into challenges on the data store and querying and everything because we ran into millions and millions of entries. So heads up on that one. If you want to solve that, then you're going to want to use some kind of data lake and delayed pushing into that because that will be tricky. So filter where you can. So the few lines of your filter and rota might not be sufficient to save your database on that. So that's just a heads up.
Yep. Thank you. We'll see where this goes.
Perfect. Thank you.
Thank you again, Luuk, for this interesting talk.